Hello, my name is Martin Langridge and I'm Head of Sales at Motion Control Products. Today I'm here with Jonathan Gulliver, who's a pump expert, and today we're going to be talking about selecting an electric motor and control system for pump applications. So hello Jonathan.
Hi Martin.
So as mentioned, we're talking about selecting an electrical motor and control system for a pump application. So when selecting the appropriate motor and control system for a pump application, what are the typical issues that you're faced with?
Well Martin, the first issue will always be what's the available electricity supply. Could be single phase, three phase or DC. And we need to think about whether the application is commercial or industrial. Typically these days in machines we're seeing DC required, 12, 24, 48 volts, but transport applications can be much higher voltages.
So what other factors do you have to consider during this process?
Well, we also need to think about the local environment where we talk about ingress protection. Ingress protection will cover exposure to water, tools, dirt and dust. Some motors have no ingress protection at all. They may be locked inside machines where you can actually see the moving parts of the motor, but the machine itself does all the protection. Conversely, others will have very high levels of ingress protection where we talk about 69K, where we protect the motor against high pressure jets of water, and sometimes the motors may be even submersible. We need to think about how sophisticated the application is. There are some very simple on-off applications where typically we might be transferring fluid from one place to another, or in the other extreme there'll be much more sophisticated control systems.
So could you give an example where the control of a pump's output would be simple and even contained within the pump?
A good classic example is filling a car with petrol or diesel. At full speed, when you hold the nozzle fully open, the pump's just running away with the motor. At slow speed, the pump will be bypassing, so the fluid is going round and round through a valve inside the pump, and the motor itself is still running at roughly the same speed. That's a traditional system. It works, it's very effective, but it is rather inefficient because all that fluid's going round and round without actually achieving very much.
Okay, Jonathan, so what are the considerations when it comes to the required speed, power or torque?
Well Martin, we talk very much in terms of a duty point, which is a defined operating point in the application, which we define in terms of those figures: head, flow for the pump and speed and torque for the motor. For an OEM product, maybe a pump that's going into a specific machine, we can define that quite accurately and we'll know exactly what we're doing. For a pump that's sold onto the open market, the definition may be much wider. The key issue here is that in different conditions, the pump and the motor will draw different amounts of power. So for instance, a small centrifugal pump will draw more power at an open valve than it will at a closed valve, and that can be more difficult to define in the open market application.
So how does temperature impact your decision making?
Temperature is very important, Martin. Motors have a specific temperature which mustn't be exceeded, and when they start operating they'll immediately start to warm up. The critical factors will be obviously the application and the ambient temperature and cycles that the pump and the motor have to operate. Remember, motors will have a defined capability at a certain ambient temperature and a different capability at another temperature. Many motors these days are fitted with thermal cutouts, so that in the event that the maximum temperature for the motor is exceeded, the motor will cut out. But we really shouldn't be seeing that. We should be getting our application right and studying the parameters required so that the motor and pump operate effectively.
And how can the temperature of the unit be maintained within its operating parameters?
The classic way to maintain the temperature of a motor is to use a fan, and that fan is normally fixed on the back end shaft of the motor. The problem with this may be in certain IP categories it may not be acceptable to have a fan. Bear in mind also that in many pump applications the pumped fluid will take heat away from the motor.
So can you give us more of an insight into these motors and their applications?
Well, if we start with the simple motors, we can consider mains induction motors, which are good for being rugged, reliable, operate at a fixed speed, which will slow down slightly when they're loaded. But these are carrying out a large number of classic duties. Speed can be changed with an inverter. Also, we can look at brushed DC applications, which are also rugged and reliable. Brush life will control the life of the product, but is often sufficient for simpler applications. Then we move on to more sophisticated applications where we look at brushless DC and other control systems.
How about metering pumps? How are they controlled?
Metering pumps are an important different application. We typically look at peristaltic or piston pumps. We're looking at a type of pump which displaces a fixed amount of fluid for every cycle or stroke. And here the motor needs to take charge of the pump. It won't be something else like a flow meter which takes charge and says what it wants to see. So the motor's taking charge of the pump, and we'll typically use a stepper motor or a motor with a good quality encoder feedback here in that type of application.
So finally, what are some of the common themes in the pump industry when selecting appropriate motors?
The main theme we're seeing now, Martin, is the requirement for more and more control. As an example, we see more and more requirements for maintaining the temperature of electronic control systems, and that temperature needs to be maintained within quite a narrow range, and a traditional on-off system just doesn't cut it and won't work accurately enough. So in these applications we're seeing more and more requirement for variable speed drives, typically operating with brushless motors and speed control systems where the speed of the motor is controlled by a PWM signal, which is coming from a protocol such as CAN or EtherCAT.
Thank you for that, Jonathan. We hope you found that useful. If you have any questions regarding the content of this video or any questions beyond what has been shown in this video, please contact one of our engineers at the below contact details.